Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, before I begin my lecture for this morning, I'd like to congratulate to all of you. Okay, congratulations to all my students for accepting this offer and taking the opportunities in your next studies in here College Matriculasi Pulau Pinang. And I do hope that all of you enjoy it, and we will be together for this semester, might be we're going to join again for the next second semester until you reach your dream and you may further continue your studies in the next first degree universities. Okay, so right now, as you see on the screen here now, we are on topic 1, number system. Okay. So before that, I'd like to introduce myself to all of you. Okay. Well, my name is Mr. Megat Faizul Khairi. Oh, sorry. Okay. There you go. Okay, so now we continue with the first topic for this semester. We're going to focusing on the three different parts of this. First is real numbers. Okay, the first is real numbers. Second is complex numbers, and the third one is indices, surds, and log. Okay, so for real numbers and complex numbers. So let's take a look at this one here now. These all are the definition of numbers. We define the natural, whole numbers, integers, prime numbers, rational, and irrational numbers. Okay, there's also part B then. Represent rational and irrational numbers in decimal form. So then please refer to your lecture notes. Okay, refer to your lecture notes, and you may fill all complete the notes for your own reference. Okay, represent a complex number in Cartesian form. Define the equality of two complex numbers. Determine the complex number is in polar form, and compute the conjugate of a complex numbers. Okay, let's see what is complex number is. Okay, so which I think that for this one you may refer to the lecture notes and complete the notes by yourself. So the natural numbers, positive numbers are used for counting. Prime numbers, okay, prime numbers, which I think that you have you noted that is numbers that are greater than 1 that can be divided by itself and 1 only. Okay. Okay, so then whole numbers. Integers, whole numbers including their negative. Okay, so positive integers and negative integers. And non-even numbers and odd numbers. Okay, you just recall, I'm not going to explain everything one by one. Okay, and then the rational numbers, which is we call terminating and also repeating here 3.2.333 so on, and this one here 0.454545 and so on. Okay, irrational numbers. Irrational numbers in decimal represented non-repeating here. Okay, and real numbers. Sorry, recall the symbol is not okay, you may refer to the lecture notes. Is all that. Okay, the relation of set numbers. Okay, I think that is very clear in your lecture notes, so I don't think I'm going to explain this one by one. Okay, so example number 1. we are going to define or identify the set of natural, whole, prime, even, and negative odd numbers. From the set numbers is given here, okay, from the set numbers is given here, we're going to identify one by one. Okay, so the natural numbers, whole numbers, prime numbers, which numbers that are greater than 1, that divide by 1 and itself. Okay, 8 can be divided by 2 or 4, so it's not a prime numbers. Okay, even numbers, negative integers, and odd numbers. Okay. Example 2. So given in the set of numbers here, so find the set of, okay, which I think that the boxes you can refer to the, well, recall in your lecture notes, there's a symbol of, might be real numbers or integers and all that. So which is 4, okay, so I have no idea what's wrong with this. So we call the lecture, the PowerPoint lecture notes, that we cannot define or read the symbol, but then you can refer to the lecture notes. It's all that. Okay. Okay, number line. The set of numbers that corresponds to all points on number line is called a set of real numbers. So the real numbers on the number line are ordered in increasing magnitude from the left to right, increasing from negative, okay, negative infinity to negative 4, negative 3, negative 2, and so on until positive, okay, magnitude from left to right, 1, 2, 3, 4, 5, and positive infinity. Okay, so we are going to look at this one here now. Open interval A, B. Okay, this open bracket we call as an open interval A, B, or X is greater than A and less than B. For example, if I have 2 until 5. Okay, so 2 to 5 here, or I make it as a symbol of the number line here from 2 to 5, meaning the list of numbers here is not, okay, since there is an open interval, means that it's not equal to 2. So after 2, it begins with 3. 4, is it include 5? No. Okay, this does not include 5, so it's just 3 and 4. Okay, close interval A and B. So if I guess again using the set number line here, 2 until 5, okay, using the symbol of this dot and dot here. So the list numbers that represent this number line is 2, 3, 4, and 5. Okay. Okay, half open interval. Half open means that is either open on the left side and close on the right side, or close on the left side and open on the left side. So first one here, which is 2 until 5, okay, open and close. So the list numbers, we call the numbers that represent by this number line here, which is, okay, it's open, it's not include 2, so it begins with 3, 4, and 5. And then, for this one here now, which is 2 until 5, okay, close on the left side and open on the right side here, from left to right. So, it begins with 2, 3, 4, what about 5? No, it's not included 5. Okay, it's just 2, 3, and 4. Okay, infinite bound. For this one here now, okay, x less than b, or from b to negative infinity. For example, if x less than 2, so from number line of 2, then here x less than 2, what's the direction? To the right or left? Yes, to the left. So if to the left hand is begin with 2, 1, 0, negative 1, negative 2 until negative infinity to the left. Okay, and then what about here? This one here now. Okay, less than or equal to b. So then 2 here. Okay, this does not include 2, so it begins with 1, 0, and so on. And this one, it begins with 2, so 2, 1, 0, negative 1, and so on. Okay, what about this one here now? Greater than a, or a to positive infinity. So it's begin. Let's say, imagine that this is 2 here, from 2 to positive infinity, and this one here now, let's say 2, close bracket or dot here. Yeah. So then this one, it begins with 1, 2 is 3, 4, and so on. And this one here, it begins with 2, 3, 4, and so on. Okay, that's it. So, the note set here, empty circles the end of point of an interval on the number line, and then circle the end point of a closed interval on the number line. Okay, so you just read all this and here. Intersection and union of interval. Okay, so now intersection and union operation can be done on intervals. For example, if a is 1, 6. Okay, look at this one here now, is a close bracket and open bracket, open and open. Okay, so let's take the first, we call for a here, it is 1 until 6. Okay, 1 with a close bracket here until 6. Okay, and then sorry then, from negative 2 until 4. Okay, from negative 2 until 4. Okay, so then now so A intersect B. The set, okay, set A and set B. When A intersect B, meaning where we find out where will these two lines intersect each other. It's not here and it's not here, but it intersect here. Okay, so then it is from 1 until 4. Okay, A set A union set B. Union means we taking them all. Okay, so open bracket and open here. So it is from negative 2 until 6. And look at this one here, open bracket and also open bracket. Okay, by using number line, find each of these following. Okay, the first one here, from 0 until 5, and then 4 to 7. So the first one here, the first set here, from 0 until 5. Okay, and this side 0 is a close bracket, so close tens here. And then 4 to 7. Okay, both are open bracket. So union, so we take them all. So then it is equal to from 0 until 7. Okay. Now, from negative infinity until 5. Okay, so negative infinity until 5. So we just imagine that it is from 5 to negative infinity. And then we got negative 1 here, and then 9. So from negative 1 until 9. So intersection, intersect, where do they intersect each other? What about here? No. Here, there's no line at all. Okay, what about here? There's only one line for this. And what about here? Yes. So then, the answer for this set is negative 1 to 5. Okay. Okay. And this one here now, we look into this part first. Okay. Before we combine the answers of this with this one. Okay. The first one, from negative 4 until 2. Okay, negative 4 until 2. And then from 0 until 4. 0 until 4. Close bracket. Okay. And the sign here is union. Union means all. Okay. So for this part here now, it is from negative 4 until 4. So now let's take this and combine with this one here now. Okay, from negative 4 until 4. Open and close. From negative 4 until 4. And then from negative 2 until 2. Okay, close bracket and open bracket here. And then come up with a sign of intersection. Intersection means that where do they intersect each other? So then is from negative 2 until 2, and this is negative 2 until 2. Okay, let's continue. Complex numbers. Okay, now what is I? Okay, consider the equation of x squared plus 1 equal to 0. Okay, this one is not equal, it's not similar to x squared minus 1 equal to 0. Class, please be careful. Okay, so for x squared minus 1 equal to 0, then we can factorize with x plus 1 and x minus 1 equal to 0. Then we got x equal to negative 1 and x equal to 1. Okay, with a sign of negative here, x squared minus 1. So what about x squared plus 1 here right now? Okay, so just imagine that if I bring it here with x squared equal to negative 1 and square root of left and right side, x equal to square root of negative 1. Is that it? Okay, x squared and x equal to plus minus on square root of negative 1. Square root of negative 1 we cannot define as we define the numbers of 2, 3, 4, 5, which is all real numbers. Square root of 4 equal to 2. Square root of 9 equal to 3. Okay, square root of 5 equal to 2.45 something like that. But what about this one here now? No real number satisfy x squared plus 1 equal to 0. Okay, so square root of negative 1 is called the imaginary number or imaginary part. So it's denoted by the term of I. Okay, so I equal to square root of negative 1. I square equal to, okay, I square equal to, okay, if I make this one here as an I multiplied with I, so I is square root of negative 1. So that's square root of negative 1 times square root of negative 1. Okay, square root, we change in the turn into indices form, which is square root negative 1 power of half and negative 1 to the power of half, which is also negative 1 to the power of half, multiplication, so then half plus half. Then we get negative 1 to the power of 1 equal to 1. Okay. And then I squared equal to negative 1 multiplied with I. So negative 1 multiplied with an I equal to negative I. And i's power 4, which is I squared times I squared. Okay, negative 1 multiplied with negative 1 equal to 1. Okay. So what about this one here now? I power of 15. I power of 15, which is also is I, okay, 4 plus 4 plus 4 plus, no, 4 plus 4 plus 4, 12, and then plus 2 plus 1. Okay, so we change it in the index form here. We get I power 4, just like this one here now. Okay, and then it is equal to negative I. Okay, example, simplify this. Okay, so for this one here now, it is a square root of 4. Okay, using this one, square root of A times B equal to square root of A multiplied with square root of B. So this one here, it is square root of 4 times square root of negative 1. Okay, square root of 4 equal to 2, and square root of negative 1, I. This one, it is square root of 7 multiplied with square root of negative 1, then equal to square root of 7i. And this one here now, square root of 9 divided by square root of 4 and negative 9. Negative 9, we come out with square root of negative 1 equal to square root of 3 equal to 3, square root of 9 equal to 3, square root of 4 equal to 2, and square root of negative 1, which is I. Okay. Okay. Complex number consists of two parts, where the real part and the imaginary part. Okay. So complex numbers consist of two parts with a real with, okay, look at the x, this one here, and the imaginary part, the imaginary with y and the imaginary numbers of I. Okay, so z is a complex number that's written as z equal to x plus yi, where x is a real part and yi is the imaginary part. Okay, there you go. Okay, real part is supposedly referring to the x here. Sorry. Okay. Okay, if z equal to 3 plus 5i, so the real z, which is the real part, which is z here is 3, and the imaginary part of z here is 5. So what about this one here, negative 2 plus 9i? So the real part here is negative 2 and imaginary is 9. Complex numbers are not ordered and cannot be represented on the real number line. Okay, for this one you refer to the lecture notes, which I think that is stated or printed there. Okay. Okay, So if A plus BI equal to C plus DI, when A, B, C, and D are all element of real numbers, then A equal to C, okay, element of real numbers, then A equal to C, this and this, and B with D, B with D, because B and D is an element of real imaginary numbers, element imaginary part, which is I, and also I then. Okay, so x plus yi equal to 2 plus 3i, then compare this to x equal to 2, y equal to 3. Okay, let's take a look at the basic operation here. It's just like 2 plus 3i, okay, 2 plus 3i, positive and positive times 4, which is positive 4, positive times positive is positive, and then 5i. So then 2 plus 4 equal to 6, 3 plus 5 equal to 8i. And this one here now, it is 10 minus 2i, 10 minus 2i, negative times 5 minus 5, negative times negative equal to positive I. So 10 minus 5 is 5, negative 2 plus 1 minus I. Okay. Multiplication. Okay, for this one here now, first we multiply this imaginary number, real part with this one here, which is equal to 2 times 2 equal to 4. Then 2 times negative 3i. 2 times negative 3, negative 6i. Then this one here, 3i times 2 equal to 6i. And 3i multiplied with negative 3i. Positive times negative, negative 3 times 3 equal to 9, and I times I squared. Okay, so negative 6i plus 6i, clear. Okay, so 4 minus 9, and I squared, don't forget that just now we agreed that I squared equal to negative 1. So multiply with negative 1 here, negative times negative, positive, so 4 plus 9, 30. There you go. So what about this one here now? 3 times 10 equal to 30. 3 times 3i plus 9i, negative 2i times 10 minus 20i, and negative 2i times 3i, negative times positive, negative 2 times 3 equal to 6, I times I squared. Okay, so 9i minus 20i minus 11i, and minus 6i squared is negative 1. Negative times negative, positive, so plus 6. Okay, so 30 plus 6 equal to 36 minus 11i. Okay. Okay, division. If z equal to a plus bi, then it's complex conjugate. Okay, I think that you're familiar with this term of conjugate. Okay, it's denoted by z bar or z star, and it's written as z bar equal to a minus bi. Okay, this is z, and this is the conjugate. So what makes it different between these two? Yes, you change the sign of the imaginary part from positive to negative, or the other way around. Okay, negative to positive. The conjugate of a complex number is obtained by changing the sign of the imaginary part. Okay, not the real part, but imaginary. Example 2, complex number. Okay, so complex conjugate, z equal to 2 minus I, then z conjugate here is 2 plus I. Okay, this one here. And what about this one here now? Yes, Z star is negative 8 minus 6i. And what about this? Z star equal to, yes, negative 2 plus 3i. There you go. Product of a complex number is conjugate. Okay. Product of a complex number and its conjugate. Product means that multiplication between, recall, the Z and the Z bar. We call the complex number of Z and its conjugate. It will give you one value without any I left. There is no I left, means there is a real numbers here. Okay, for example here, 2 times 2 equal to 4. 2 times negative 3 equal to negative 6i. 3i times 2 equal to positive 6i. Positive times negative, negative 3i times 3i, 9i squared. Okay, negative 6i plus 6i, clear between these two, and then, okay, sorry for a while. Okay, and then I squared equal to negative 1. So then, sorry, there's something wrong with the board here. Okay. So negative times negative equal to positive. Okay, so plus 9. 4 plus 9 equal to 30. Okay, any complex number, sorry, just now here now. Okay, any complex number A plus BI and a complex conjugate, and the product of A plus BI is a real number. This fact is used to simplify. Okay, this fact here is used to simplify the expression where the denominator, where expression of denominator is a quotient. Of a quotient is a complex number. Okay, we'll see what it all means here. Okay. What about this one here now? It multiplied with negative 3i, negative 3i. Okay. So 2 times negative 3 equal to negative 6i, and negative, okay, 3 times negative 3, negative 9i times I squared. Okay, so then negative 6i, negative 9i squared equal to negative 1. So negative times negative become positive. So here it is negative 2 over 3i. Okay. Okay. It is okay. So this one here now, multiplied with 1 plus 10i divided by 1 plus 10i. Okay. So then 4 times 1 equal to 4. 4 times 10i, 40i. Divide by 1 times 1 equal to 1. 1 times 10i plus 10i negative 10i times 1 minus 10i, negative times negative, and negative times positive, negative 10 times 10, 100, and I times I squared. Okay, 4 plus 40i divided by, okay, now 10i minus 10i. Clear. So what's left here now? 1, and I square is negative 1. So negative times negative, positive. So 1 plus 100 equal to 4 plus 40i divided by 101. And we simplify this in the in the form of a plus bi. So it come out with 4 over 10 plus 40 over 101 I. There you go. Okay, a plus bi. Okay, next. Okay, now if z equal to this one here, find z bar in the form of a plus bi. Okay, before we can find the value of z bar here, we need to simplify this first. Okay, simplify this means that it is z, which is 2 plus I divided by 1 minus I. Okay, the denominator is in the complex numbers form, real part and imaginary part. So we're going to multiply this with 1 plus I divided by 1 plus I. Okay. So then, slowly 1 by 1, 2 times 1 equal to 2, 2 times I equal to 2I times 1 equal to an I, and I times I squared. Okay, and now 1 minus I multiplied with 1 plus I. So 1 times 1 equal to 1, 1 times I equal to an I, negative I times 1 minus I, and then negative I times I minus I squared. Okay, and change this first. I square is negative 1, and also I square, which is negative 1. Negative times positive, negative. Okay. Okay, 2i plus I, 3i. 2i plus I, 3i, and 2 minus 1 equal to 1. Okay. And then, okay, now, I minus I. Clear. Okay, this is negative 1. Negative times negative, positive. So 1 plus 1 equal to 2. So we change in the form of a plus bi. For this one here is 1 over 2 plus 3 over 2i. This is z. This one here. Okay, so this is our z. This is our z. So our z bar or conjugate of this z bar equal to 1 over 2 minus 3 over 2i. That's it. Okay, let's double check here. I minus I, okay. And then negative I times I, negative I squared. Negative I squared is negative 1. Negative, negative become positive. So 1 plus 1 equal to 2. That's it. Okay, solve the following equation of the complex numbers. Okay, now this is, okay, 6 plus 2i, okay, 1 minus 3i minus z. I'll copy all the question again. Okay, so just imagine that we bring this to the left side and then with a negative z. So negative z equal to 6 plus 2i, okay, and bring this to the left side minus 1 minus 3i. Okay, and then Z okay, sorry again. Okay, Z equal to negative and positive here, so you come out with 1 minus 3i minus 6 minus 2i. Okay, so then open up the bracket here, 1 minus 3i, negative 6, negative become positive, 2i. So then 1 minus 6, negative 5, negative 3 plus 2 equal to minus I. Okay, class, sorry, there's a mistake then. 6 plus 2i, 6 plus 2i. Okay, so then we open our bracket here, 1 minus 3i, negative 6, and negative with positive, negative 2i. So 1 minus 6 equal to negative 5, negative 3 minus 2, negative 5i. Okay. Okay, the question here just now here is negative 3 plus 11i. Okay, in this case, we come out with Z equal to, bring this as a denominator for this one here now, negative 3 plus 11i divided by 3 minus I. Okay, so simplifying this means that we're going to multiply the conjugate of denominator 3 minus I with 3 plus I. 3 plus I. Okay. So then negative 3 times 3, negative 9, negative 3 with I, minus 3I, 11I times 3, plus 33I, and 11 times I, plus 11I squared, divided by 3 times 3 equal to 9. 3I and negative I3 cancelling each other then, okay, so negative with positive, negative I times I squared, because this and this are 3 plus I is a conjugate of this one here, so you can just guess that is come up with this one. Okay, so then I squared is negative 1, so negative times positive, negative, so negative 9 minus 11, negative 20, 33 minus 3 plus 30i divided by, and I squared is negative 1, negative times negative become positive, 9 plus 1 equal to 10. Okay, so divide by 10 each, so you come up with negative 2 plus 3i. There you go. Okay, complex number can be represented in an Eigen diagram. If Z equal to A plus BI, the Eigen diagram shown as below. Okay, most of the time when we come up with these two, we call sign of okay, most of the time we put as an X and also Y. Okay, in this case right now, we're looking into the real part and imaginary part. Okay. Okay, if Z equal to A plus BI, then the Eigen diagram shows that the P coordinate of P with A and B. Okay, this is an A and here it is B here. Modulus and argument of a complex number. If the length of O to P is called the modulus of the complex number of ZA plus BI and is written as an A plus BI, the modulus that here, okay, so modulus of Z equal to square root of A squared plus B squared. Okay, so the angle of theta is called the argument and written as argument of the Z. Okay, and theta must be between the positive real axis. Okay, theta must be between the positive real axis and line of complex number on the Eigen diagram. Okay. Okay, so on the first quadrant of this, where you can see here the coordinate of P, A, B, okay, this is the coordinate of A and coordinate of B in the first quadrant here. So argument of Z equal to theta equal to arctangent of B over A, and theta in radian or pi. Okay. For the complex number which are not in the first quadrant, first find the basic angle. The basic angle alpha equal to arctangent of B over A with a modulus. Okay. And then for the first quadrant, okay, real part and imaginary part. The first quadrant here, second quadrant, third quadrant, and fourth quadrant. So the first quadrant is alpha itself. Second quadrant is theta minus alpha. Third quadrant is negative theta minus alpha, and the fourth quadrant here is negative alpha. Okay. So then, okay. So just imagine that this is the first quadrant. So this is the alpha, and this one here now. Okay. Theta represent the 180. So 180 minus alpha, it gives you here. Okay. Okay. Represent these complex numbers in Eigen diagram. Calculate the modulus and argument of Z. Okay. So now, guys and girls, get ready. We are going to analyze and look what's going to happen to every single example that we see on the screen here now with an A, B, C, and D. Okay. So for Z equal to 1 plus I, sorry. Okay. Okay. Real part and imaginary part. Okay. So the coordinate is 1 and 1i. 1 plus 1i. Okay. So with 1 and 1. Here. Okay. So then from the origin point to the point of 1 and 1. Okay. So then modulus of Z is square root of 1 square A and B plus 1 square equal to square root of 1 plus 1 square and 1 square is 1 plus 1 equal to 2. Okay. And it lies in the first quadrant. In the first quadrant, so then the argument of Z equal to arctangent of 1 over 1, okay, equal to arctangent of 1. You may use a calculator for this one. It gives you 45 degree or pi over 4. Okay, pi is 180. Okay, pi 180. So divide by 4. Divide by 4. Divide this, you get 90 and 90. Divide another 2 here, and it is 45 and 45. Okay, pi over 4. Okay, that is the first one. Next one, okay. Okay, so the first one here is negative 4 and 1. Okay, this one here, negative 4 and 1. From origin point to the point of this here. Okay, so then for this one, z equal to square root of negative 4 square plus 1 square. The square root of negative 4 square equal to 16 plus 1 square is 1. It is square root of 17. Okay, and then it lies on the, okay, this is the first quadrant and it lies on the second quadrant. Okay, so alpha equal to arctangent of 1 over negative 4. Okay, modulus here. So arctangent of this, it gives you negative 0.24498 radian. Okay, it lies in the second quadrant. So then theta here equal to pi minus alpha. Okay, so which is pi minus 0.24498 equal to 2.8966 radian. Okay, so tangent of this alpha equal to 0.244 here. So theta equal to, so we call theta equal to pi minus alpha here, which is pi minus 0.24498, and you get it one here now. Okay. Okay, this is the basic angle of alpha and this is the theta. Okay, now it is, okay, this is imaginary part and it's a real part. So negative 2 here, and also negative 2i, negative 2 here. Okay, so intersect here. So we make a line from the origin point okay, there's something wrong with this pen here. I have no idea what's going on. Okay, from this point to this point here. Okay, so then equal to square root of negative 2 square plus negative 2 square. Okay, negative 2 square equal to 4 plus negative 2 square equal to 4, then square root of 8, which is, okay, simplify this. Okay, it is square root of 4 times square root of 2, and square root of 4 equal to 2 square root of 2. There you go. Okay, and then alpha equal to arctangent of, okay, b minus a, which is negative 2 divided by negative 2, and it is arctangent of 1. Okay, this one here, it gives you 0.7854. 0.7854 radian. Okay. Class, you may just use the calculator to get the answer of this. So then, this is the third quadrant, first quadrant, second quadrant, and the third quadrant. Okay, so then here now, a third quadrant is theta equal to negative pi minus alpha. So in this case, it is negative pi minus alpha, where alpha is negative 0.7854, 0.7854, it gives you negative 2.3562 radian. Okay. And last one here should be z equal to 2 minus I. Okay, when 2 minus I, okay, 2 and negative 1. Okay, from here, okay, so modulus of z equal to square root of 2 square plus negative 1 square. 2 square equal to 4, negative 1 square is 1, so the square root of 5. Okay, and then alpha equal to arctangent of b minus b divided by a, which is negative 1 divided by 2. So then it is arctangent of 1 over 2, or it is 0.46365 radian. Okay, so this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. So fourth quadrant, in the fourth quadrant here, okay, it is theta equal to negative alpha, so then it is at negative 0.46365 radian. Okay. A polar form of a complex number. Okay, so the polar form, let z is a plus bi, represented by the point of A and B. Point A, okay, point A, which is AB here, on the Eigen diagram. Then R equal to square root of A square plus B square, or modulus of Z. Okay. We are going to write this in this form, where R is the modulus and theta is the argument. Okay. It's all the same question that we discussed just now. A, B, C, and D. So then, we're just going to use recall the answers that we got just now. We call the modulus of Z and the value of theta, and we can write down in the polar form. Okay, so please refer to recall the answers that we get just now. Sorry. Okay, so the first one here now. Okay, please refer to the previous answer, and we write down is in the form of square root of 2, okay, cos pi over 4 plus I sine pi over 4. Okay, just to double check. Okay, which I think that, sorry. Okay, which is the z is square root of 2 and the argument of z is pi over 4 here. Okay. So we just use all the answers that we get just now in this part. Okay. Okay, what about this one here? It is square root of 17 cos 2.8966 radian plus I sine 2.8966 radian. Okay. Next one, it is 2 square root of 2 cos negative 2.3562 radian plus with I sine negative 2.3562 radian. Okay, and this one here, it is square root of 5, okay, cos negative 0.46365 radian plus I sine negative 0.4635 6365 radian. 46365 radian. There you go. So this is in a record in polar form. Okay. Okay, class. So from example 8, which I think that I'm going to solve one question, which I'm going to solve question A only, and you try yourself to solve the question of B. Okay. Okay, express answers A and B in polar form. Okay, so just now where Z1 equal to, Z1 is 2 minus I, and Z2 equal to negative 1 plus 3I. Okay, so Z1 multiplied with Z2 equal to 2 minus I multiplied with negative 1 plus 3I. Okay, 2 times negative 1. This is multiplication dot. 2 times negative 1, negative 2. 2 times 3 equal to 6I. Negative I minus 1. Positive I. And negative with positive, negative 3I squared, where I squared is negative 1. Okay, 6I plus I, 7I, negative with negative become positive, so 1 times 3, so negative 2 plus 3 equal to 1. 1 plus 7I. Okay, so then modulus of Z1 times Z2, which is modulus of A plus BI here, 1 and 7, square root of 1 square plus 7 square. Okay, 1 plus 7 square is 49, and 49 plus 1 is square root of 50. Okay, we simplify this as a square root of 50, 50, 25 multiplied with 2. Okay, 25 times 2 equal to 50, so this is square root of 25 is 5 square root of 2. Okay, so okay, and then the argument of z1 dot z2, which is arctangent of 7 divided by 1, which is equal to 1.429 radian. Okay, so in polar form, z1 multiplied with z2 equal to 5 square root of 2. Okay, cos 1.429. Okay, sorry for what. Okay, we cannot change that. Okay, cos 1.429 radian plus I sine 1.429 radian. Okay, so you test for the next one, or B here, test by yourself, and I'll give you the answers of this. Okay, you just find out by yourself, and z1 divided by z2 equal to square root of 2. Okay, cos 3 over 4 pi plus I sine 3 over 4 pi. There you go. This is your final answer. So test by yourself, see whether you can get as answer as given here or not. Okay, so then the conclusion, you can just see it by yourself, and that's all for today. And I do hope that all of you happy, and till we meet again on our next lecture. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.